Hello students, I hope you are getting my voice. Yes, no, no. Someone has asked the question number 43 and 40 the earlier classes and study hours. And simply just we are asking. We are simply wasting time and we are asking. See here. So question number 43. Already I have discussed this in the previous study hour. Look here. Right? So what you have to understand here is mass will be proportional to radius cube because density equal to mass by volume. Density is equal to mass by volume. Already similar kind of questions just we have worked out somewhere. So density equal to mass by volume. So mass is proportional to mass equal to um, mass equal to density into volume. So you can say mass is directly proportional to r cube. 4 by 3 pi r cube. So r cube. So you can replace masses with radii if they have given in terms of radii. This you have to keep in mind. Okay. This you have to keep in mind. Next. By making use of that, just and if you substitute the values here, you'll get the answers as v1, v2 as this. This is for question number 40. This is for question number 43. Now question number 42. Let us see briefly. 43 and 44 also similar one only. Mass we have to replace with radius cube. Okay. Right. Yes. Now let us see question number 42. Now let us see question number 42. Question number 43. Yesterday's study hour. Go through it. Go through it. Okay. Now let us discuss question number 42. Level 1 exercise. I think level 1. What is that? Question number 42. Question number 42. Level 2 exercise 1. Level 1 exercise 1 42 43. Okay. Now just first let us finish this. One more question from level 2. Then we will go through that. Level 2 exercise 1 question number 42. Question number 42. I think Preeti, are you there, Nana? 47. This is actually it is level 2 exercise 1. Right. So the question is let me read the question once. From the top of a tower of height 100 meter, a 100-gram block is dropped freely 100 meter per seconds simultaneously. Full stop. They collide and stick together. And then the common velocity of collision is take small g is equal to 10 meter per second square. Okay. So how to deal with this kind of questions? See here. Here you have to apply the concept of relative velocity. Guys. Here you have to apply the concept of relative velocity. So what is that? Let us see here. So if you can, let us consider if you consider a tower is a of height h is equal to 100 meters. Okay. from the top of this tower of height this, a block of mass, let us say this is m1, block is m1, is dropped means its initial velocity is 0. Block of 1 is dropped means its initial velocity is 0, or you can say its initial velocity is 0. Block of mass is how much? 10 gram. That is yeah. Let us mark here. Block of mass m1 is equal to 10 gram. If you here it is given in meters, and if you want in SI units, you have to convert this into SI units as 10 into 1 gram equal to 10 power minus 3 kilograms. And its initial velocity is 0. At this time, a small bullet is fired, a bullet of mass m2, which is equal to 6 gram, can be expressed as 6 into 10 to the power minus 3 kilogram, is fired up with a velocity, let us say u2 is equal to 100 meter per second, upward direction simultaneously. The moment it is dropped here, with initial velocity 0, this is fired up with velocity, this is u1, this is u2, with velocity 100 meter per second. Now the point here is, after some time they will collide each other. After collision they will stick together and they will move in one particular direction. Whether they will move it downward or upward, that you have to understand. Okay, so to understand that, let us consider that they will meet after some time t. What should be the final velocity of m1 and final velocity of m2, and hence at that particular moment what should be, which will be having larger velocity, and hence say yeah, somewhere here after some time t they will meet. So the final velocity final velocity, if you want to find, you have to use a relative velocity concept. With, even though it is dropped with respect to this, that is with respect to bullet velocity of the block, so relative velocity of the block with respect to bullet, capital B is bigger block, a small bullet is small b. Okay, velocity of the block with respect to bullet, velocity of the block, even though it is released, but with respect to this, as it is moving, it appears like it is moving with this, say, its same velocity towards it, downward direction. So it is nothing but 100 meters only. Distance between them is 100 meters. Okay, and here gravity is acting on this downward direction, gravity is acting on this also downward direction, so both are in the same direction with same gravity, constant gravity is acting. If constant gravity is acting, gravity, acceleration due to gravity, or acceleration of the block with respect to bullet will be observed to be 0, because both in same direction, means you have to take the velocity by time. Acceleration is equal to what? Velocity by time is equal to velocity by time. You may not get here because acceleration is 0. So if you think about the other way, velocity is equal to distance by time, whether you will get the time or not, yes, you can get. So by using that point, what is that? Velocity, relative velocity velocity of the block with respect to bullet is equal to, velocity is equal to what? Distance by time, relative distance, s by t. From this you can say t is equal to s by vbb. S is what? How much? 100. And velocity of the block with respect to bullet is also 100. So you get 1. That means with respect to this, to reach with each other, or to travel this much distance, in second, the relative distance of this to travel this, that means after this time they will collide with each other. That is the meaning of it. You can say it is equal to t equal to 1 second. After this they will meet. That means they will collide at that moment. So at that moment, what is the velocity of the block and what is the velocity of the bullet? If you can find the what is that, small bullet also, they will collide. As bullet is moving up and this is moving down, they collide. Then depending on the larger velocity, larger mass, larger velocity and larger momentum which is having, in that direction it will move, the bodies will move. So to understand that, we have to find out the final velocity of the first one. From the equation, from one of the equations of motion, v is equal to u plus at, because v is equal to u plus at. Here u in, for this initial velocity is 0, a is minus g, so minus g into t is 1, so we'll get minus g. So here that v is also downwards, equal to minus g into 1, or this implies you can say v1 is equal to g. is equal to 10 meter per seconds. V1 downward direction. Down for V1 it is downward direction. Just at this moment, and that is after 1 second. Whereas V2 final velocity of this after 1 second is V2 is equal to its initial velocity is not zero. It is projected up with some initial velocity 100. So its initial velocity is can say U2 plus AT. So here U2 is 100 and G of course will be down only minus G into 1. G is 10. So you can write it as 100 minus 10 is 90. So you can say V2 is equal to 100 minus 10 is 90 meter per seconds. Here V2 will be in upward direction. Upward direction. V1 will be downward direction. So because of its larger velocity, its momentum will be larger. So from law of conservation of momentum, actually this will be considered as initial velocity before collision. Because it is having larger what you call velocity, you can clearly understand that. So this is its momentum is its mass is 10, its velocity is 10. So 10 into 10 is 100. Its momentum is 6 into 90, it will be 540. So it's this momentum, upward momentum is more. So after collision, they will combine, stick together and move in upward direction. So we have to take this as a final velocity after collision. Listen this carefully, guys, and try to go through this explanation once again if you are getting any confusion, and follow the steps very clearly. Okay. Now. And for this particular part, collision part, before collision and after collision, if you observe, actually what you are asked to find here, that also should be clear. What you are asked to find, it is mentioned that they collide when this block is moving down, bullet is moving up, they collide and they will move, stick together and move with common velocity. So this is the point. What is the common velocity is the question. What is the common velocity is the question. What is the common velocity is the question. Okay. Common velocity v1 is equal to v2 final velocity. Final velocity of f1, what is that here asked to find. So for that purpose we have to here at this point now we have to observe for this finding v1 v2s we have to find t here, then we have to find v1 v2s. Now we have to use this what do you call uh, law of conservation of momentum. According to law of conservation of momentum, m2 v2 with vector notation plus m2 v2 divided by total mass. So it is equal to m1. M1 is block mass 10 grams. 10 grams. Okay. Or 10 into 10 power minus 3 is moving down. The another is moving up. Another is moving up. If both are moving in same direction, we can take plus. Downward if you take negative, upward if you take positive, this will be negative. With sign conventions, if you want, you have to take this as negative. Then divided by total mass. Total mass is 10 gram plus 6 gram is 16 gram. So you can write it as 16 into 10 to the power minus 3 kilograms. Here 10 power minus 3 is common and it will get cancelled out. Then you can write 10 into 10 100 minus 100 minus 100. This is plus and 6 into 90. 6 into 90 is 540. 540 divided by 16. It is equal to 540 minus 100 is 440 divided by 16 is v. So this is the final velocity. This is approximately, if you have observed the options, 27.5, 150, 40, 100. Obviously it should not be. It is 15 means approximately if we take 15. Okay, 16 you can do do the calculations. 16 3 16 2 32, 16 3 to 32. So it goes 3 2 times, then 27.5 will get. We simplify this, we get 27.5 meter per seconds. This will be the common velocity after collision, guys. So practice this collision calculations properly and try yourself. Someone has asked level 1 exercise 1 42 43. Level 1 exercise 1 exercise 1 42 43. Right. So what are this 42 43? Question number 42, page number 38 is given by a body of mass 10 kg moving with a velocity of 5 meter per second hits a body of 1 gram at rest. The velocity of the second body after collision, assuming it to be perfectly elastic collision, is. Yes, we have to use the formula. of final velocities in elastic collision, perfectly elastic collision or elastic collision, guys. So let us see that. So question number 42, page number 38. Question number 42, page number 38. A body of mass 10 kg, a body of mass 10 kg, moving with the velocity of u is equal to 5 meters per second, 1 gram. So there is another body also. So let us consider this is u of m2 is equal to 1 gram. 1 gram means in kilogram. If you want, you can write it as 1 into 10 to the power minus 3 kilogram, which is at rest. That means initial velocity of the second one is 0. Then the velocity of the second body after collision, the after collision, its velocity can be taken as v1, its velocity can be taken as v2. The velocity of the second body after collision, assuming the collision is perfectly elastic. Velocity of the second body after collision is what is the question. Okay, so obviously, just without calculation also, just you can remember this. There is a 10 kg block and 1 gram object. If it is heavy, this is m1, this is m2, is moving with velocity u1. It is at the loss of kinetic energy of the system is this. This also we have discussed in the previous session, guys. Just to let me show you this. It means you have to find out what is v2. Then you have to find, you're asked to find what is loss of kinetic energy. Loss of kinetic energy is equal to delta. Before collision, initial kinetic energy of the entire system is, because it is at rest, and initial kinetic energy is kinetic energy of the first block only. Okay, so it is half m1 u1 square minus after collision the first body stops, so its kinetic energy will be half m2 v2 square. So v2 you don't know, first you have to find out v2 first. So let's say this is equation of 1. To find v2, you have to use law of conservation of momentum. Law of conservation of momentum gives you m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Here u2 is 0, here v1 is 0. If they be u1, m1 by m2, m1 is 1, m2 is 2, into u1 is 4. So you get 2 into 2, 2. So 2 times it will be v2 will be equal to 2 meters per second. Once you know this, substitute it here and then you'll obtain the final value. So the final value will be 43. 4 joule. And simplifying this, we get delta k is equal to, we get 4 joule. That's it, guys. Okay, that's it. Still, does anyone is having any other question, guys? I hope we have discussed all the questions elastic collisions in level 1 exercises 1 2 and level 2 exercise 1 and 2. Only the remaining job is you guys have to practice. How many times if you practice, that much timing you can improve yourself, that much confidence you can improve yourself. Okay, practice yourself. If you can till you get confidence, if you practice, you can try. If you can do practice 3 times or 5 times, try to get clear picture of this method of questions. We come across any method, or I won't say woman boy or girl perfect, if I say okay, right. So practice makes man or woman or boy or girl perfect. So do